Okay, so we're going to look at how integration, I suppose, plays with one of our applications for differentiation, which was looking at kind of displacement, velocity, and acceleration, and all of those questions. So I suppose the use of integration in this really is just to move in the opposite direction. So differentiation allowed us to start maybe at displacement and move downwards, or start at velocity and move downwards. Integration means we're able to go the opposite direction. What that can mean in practice a lot of the times, they may start you at velocity and then allow you to maybe go upwards to displacement, downwards to acceleration. I think that idea of thinking of it as up and down can be quite helpful, and making sure that you know that a movement upward is integration, a movement downwards is differentiation. But really, that's really all that integration kind of factors into this, is this movement in the opposite direction. So acceleration is given by this formula. When t is 0, the velocity is 3 and its displacement is 5. Find the velocity and displacement of the particle in kind of a general sense here. So we should hopefully know, even just based on what we said here, that velocity is the integral of acceleration. So integrating acceleration here, minus 4t plus 2 dt is going to be minus 4t squared over 2 plus 2t plus c, which is minus 2t squared plus 2t plus c. So this is my velocity. So then velocity, it says at time 0 should be 3. So let's try it out. So velocity at time 0, minus 2 times 0 plus 2 times 0 plus c is equal to 3, which means c is equal to 3. Okay, so c is equal to 3 there. So my velocity is minus 2t squared plus 2t plus 3. Okay, integrating that then to find displacement. So displacement s of t is the integral of velocity. So integrating this, minus 2t squared plus 2t plus 3 dt is minus 2t cubed over 3 plus 2t squared over 2 plus 3t plus c. And again, we know that the velocity or the displacement at 0 is 5. So fill that in then. S of 0 is minus 2 times 0 cubed. Of course, that's just going to be 0 straight away because we're multiplying by 0. Plus 3 times 0 plus c equals 5, which is going to mean again that c is just equal to what they've said, 5. And my overall function for displacement then I can write quite easily there. Sorry, filling in for c, of course, filling in 5. Okay, so we get to our answer straight away there. Really just an example there of moving completely in the opposite direction. Looking at exam style question there for that, similarly again, we're given the velocity of this question. The first thing is to find acceleration. So bearing in mind that to go from velocity to acceleration, that's a movement downwards on our little kind of diagram here. So that's going to mean differentiating. So dv dt. So acceleration is dv dt, which is 20 minus 8t. Now we're looking for acceleration at t equals 3, so a of 3, so 20 minus 8 times 3, which is minus 4 meters squared per second. So a kind of negative acceleration there, or deceleration. Interpret John's acceleration at this time in the context of the question. So it's decreasing, which would mean he's slowing down. Okay, so his acceleration is decreasing, he's slowing down. Okay, he's decelerating essentially. Given that at s of 0 equals to 0, find the displacement function. So to find displacement, we need to integrate velocity. So we're going to integrate my velocity function, which was 20t minus 4t squared, with respect to t. That's going to give me 20t squared over 2 minus 4t cubed over 3 plus c. We know that at time 0, the displacement is 0. So at time 0, essentially, it's at this original point from which we're measuring displacement here. 0 cubed over 3 plus c equals 0, which means c is 0, and my displacement function is 10t squared minus 4t cubed over 3. Okay, so very, very quick one really, but just to kind of look at why integration maybe is relevant within that So differentiation allowing us to fully just move downwards, but integration allowing us to go the opposite direction, also to move upwards, as opposed to just moving downwards there.